Welcome all to the second part of this video on communication. To watch the previous video, please check the links given in the description. A radar system has a transmitter that emits radio waves known as radar signals in predetermined directions. When these signals contact an object, they are usually reflected or scattered in many directions, although some of them will be absorbed and penetrate into the target. Radar signals are reflected especially well by materials of considerable electrical conductivity, such as most metals, seawater, and wet ground. Radar development began in the 1930s with the work of several scientists in several countries. The first experimental radar system was built in England in 1935. German scientists also developed radar during World War II, and the technology was used extensively by all the sides during the conflict. In the 1950s, radar systems were developed for use in air traffic control and weather forecasting. The modulation technique used in the earlier generation of the radio broadcast was amplitude modulation. The quality of sound was poor and greatly influenced by interference and atmospheric conditions like weather. As radio was only form of communication, better technology was introduced with improved sound quality. The new technique used frequency modulation and was thus later known as FM radio stations. Modulation is the process by which information is encoded from a message source in order to optimize it for transmission. Modulation is the process by which information is encoded from a message source in order to optimize it for transmission. Now, let's learn more about amplitude and frequency modulation. Amplitude modulation is a modulation in which the amplitude of the carrier wave is altered in accordance with the instantaneous amplitude of the modulating signal, keeping phase and frequency constant. Modification of carrier wave amplitude is performed for the purpose of sending data or information over long distances. Amplitude modulation requires low bandwidth in the range of 10 kHz, operates in medium and high frequency ranges of 535 to 1705 kHz, has a simple circuit with only two sidebands, and receives low quality signals with poor sound quality. Frequency modulation is the encoding of information in a carrier wave by changing the instantaneous frequency of the wave. Frequency modulation is a modulation in which the frequency of the carrier wave is altered in accordance with the instantaneous amplitude of the modulating signal, keeping phase and amplitude constant. Modification of carrier wave frequency is performed for the purpose of sending data or information over small distances. Frequency modulation requires high bandwidth in the range of 200 kHz, operates in a very high frequency range of 88 to 108 MHz, has a complex circuit with an infinite number of sidebands, and receives a high quality signal with high sound quality. A communication satellite is an artificial satellite that relays and amplifies radio telecommunication signals via a transponder. It creates a communication channel between a source transmitter and a receiver at different locations on Earth. Communication satellites are primarily used for television, telephone, radio, internet, and military applications. Many communication satellites are in geostationary orbit, which is around 35,900 km above the equator, so that the satellite appears stationary at the same point in the sky. The satellite dish antennas of ground stations can be aimed permanently at that spot and do not have to move to track the satellite. The development of satellites has played a pivotal role in the exploration of space and the advancement of science and technology. The GPS satellites carry very stable atomic clocks that are synchronized with one another and with the reference atomic clocks at the ground control stations. Most receivers have a track algorithm, sometimes called a tracker, that combines sets of satellite measurements collected at different times. After a set of measurements are processed, the tracker predicts the receiver location corresponding to the next set of satellite measurements. At a moment, a set of satellites are always in contact with one receiver to provide the accurate position. 1G refers to the first generation of cellular network wireless technology. The first generation of mobile networks was an analog technology that was launched in the 1980s. The first generation mobile network was very slow by today's standards, with data speeds of only a few kilobytes per second. Despite its slower data speeds, 1G was a breakthrough at the time because it allowed people to make phone calls from almost anywhere. The second generation of mobile networks was a digital technology that was launched in the early 1990s. 2G increased data speeds to a few hundred kbps and also introduced new features such as text messaging. The third generation of mobile networks was also a digital technology that was launched in the early 2000s. 3G increased data speeds to a few megabits per second and introduced new features such as mobile broadband internet access. 4G provides, in addition to the usual voice and other services of 3G, mobile broadband internet access, for example, to laptops with wireless modems to smartphones and to other mobile devices. Potential and current applications include amended mobile web access, IP telephony, gaming services, high definition mobile TV, video conferencing, 3D television, and cloud computing. 5G mobile networks are the latest generation of wireless technology which revolutionized the way we use our mobile devices. These were deployed in 2019 and is still in progress across the globe. Thanks for watching the second part. Please let me know in the comment sections on which topic would you like to know more about.